In this final video on equation solving, we're going to look at two examples where it feels like things don't quite work out. And so we want to be able to interpret the results when we truly cannot solve the equation. So taking a look at this first example, I noticed that there is a negative. We talked about that before, that that's equivalent to a -1, and it does need to be distributed. So doing that distributed, I have 3 minus x, two negatives making a positive, plus 10 equals 5x minus 7 minus 6x. On both sides of the equation, I now have some like terms. So on the left, there is a 3 and there is a 10. They're both constant terms. And so I'm going to put them together to make them 13. So I have negative x plus 13. On the right-hand side of the equation, I have here 5x, and I have out here negative 6x, which are both variable terms, and again, like terms. So 5 minus 6 is negative x, and I have a minus 7. So far, things are going pretty well. And my next step, according to my notes, is to get my variable terms together. So looking on the left, I have negative x, so I put plus x. I do the same on the right. Negative x and positive x cancel, so I have 13, have my equal sign. On the right-hand side, negative x and positive x cancel, and I have negative 7. Here's where something has gone wrong. So I had a variable x, I was solving for it, and now it's gone because I have canceled it on both sides. I cannot move forward from this point because I don't have a variable to isolate anymore. So I'm done with the math, I just have to interpret it. When I look at what remains, I have a statement that says 13 is equal to negative 7. This is not a true statement. And so what I have shown mathematically is that there is no solution, because when you do the algebra, you don't end up with an answer. And so this is one where we cannot put in a value for x because the two sides, the left and the right, actually are not equal and will never be equal. Now, I want to show you this from a slightly different perspective. So I'm going to change my pen color here. I'll go with a dark red because it's not a wrong perspective, but it's just a slightly different perspective. So we all start with distributive and we all combine like terms. And so I have as the step negative x plus 13 is equal to negative x minus 7. Many of us prefer to add our constant terms together before we deal with the variable. And so if I do that here, I'm never a fan of negatives, so I'll add 7 to both sides. Negative 7, positive 7 cancel, and so I have negative x plus 20 is equal to negative x. Let me rewrite that based on my pen here. Now I can get my variable terms together. So if I attempt to do that, I will add x to both sides. And at this point, the x's cancel, so I have 20 equals. On the right side, the x's cancel as well. And we did see this in one problem earlier. When everything cancels on a side, we still need something there. So I will have to write in the 0, even though I don't normally write the 0 when things cancel. So I did a few more steps of algebra than I have written in the blue, but I have come to a place where the variable is gone and the remaining numbers are indeed not equal to each other. And so again, I've reached a statement that is not true, and so my answer, no matter which way I do the problem, is no solution. The reason why our notes told us to combine the variable terms first is to avoid this scenario that we just looked at in the dark red. However, both scenarios lead to the same correct answer. And so the answer to this problem is no solution. In MyLab, there will be a multiple choice option for that if you work one of the problems and it turns out not to have a solution. So let's take a look at our last example. And our last example, again, is one of those where things have gone a little bit odd and don't work out the way we expected. So when I look at this, first thing I notice again is fractions, and with fractions I do need a common denominator. So when we're looking for a common denominator, we're looking for a number that all the numbers can multiply to. So when I look at 5 and 6, they would multiply and give me 30, and 30 times 1 would still be 30. So my common denominator in this case is indeed 30. I'm going to use the same strategy I used before, and that is to multiply both sides of my equation by that common denominator. So I put parentheses around the left, and I'm multiplying by 30 over 1. Also parentheses around the right, multiplying by 30 over 1. And I'm going to take a moment to see if I can erase that wacky thing from my pen there. There we can see what's going on a little bit better. So when I multiply, I am going to distribute. So 30 times 4 would be 120 divided by 5, and then there's an x. So 120 divided by 5 is 24x when I simplify. Distribute here, there is a negative, so minus, let me write it up here, minus 30 over 6, and when I do that math, this is minus 5. On the right-hand side, because this is all over the same fraction, and I see 30 in the denominator and 30 in the numerator, instead of distributing and then dividing each by 30, I'm just going to cancel these 30s. And so that's a little bit faster method to get to 24x minus 5. Now, you might notice that both sides are the same. On the left, I have 24x minus 5. On the right, I have 24x minus 5. So in my mind, I'm like, yeah, something's different with this equation. Both sides do match though, and so that's a really important thing to note. I'm going to try some math. So I'm supposed to get my variable terms together first. If I do that, I do minus 24x on both sides. On the left, those cancel. I have negative 5. I bring down my equals. On the right, these cancel. I also have negative 5. So just like the last problem, my variable is gone. And when I evaluate what's here, I see that negative 5 is indeed equal to negative 5. So I have a true statement. And that means that the x in this original problem can be any real number. Because anything that I plug in for x, the two sides are the same. And so I'm going to get the same answer. I'm always going to get an equal statement. And so we typically describe the solution set to this as all reals or all real numbers. Again, I want to look at this from the perspective of what if you were trying to deal with the variables first instead, or the constant first instead of the variable. So we get to the point where we have 24x minus 5 equals 24x minus 5. And so if we're going to deal with the constants first, I would add 5 to both sides. Those cancel, so I have 24x equals 24x. Hopefully at this moment you notice that both sides are identical, and because they're identical, they're definitely equal, and you make the decision that it's all reals. But if you don't, this can become a little tricky, and sometimes people can lead themselves into some math errors. So one thing that we could do is I could divide by 24, trying to get that coefficient of 1. So that would cancel on both sides, and I would have x equals x. Definitely you should be noticing by now that both sides are equal. Answer is all real numbers. But what if you don't? Well, I could try subtracting x to move it to the other side, and if I did that, they would cancel and I would get 0 equals 0. And so at this stage, you have no variable left to keep doing any math. And so you have 0 equals 0, which is true, which leads you to the solution, all real numbers. So we see in both of these examples that are just a little bit different than your average ones that can't be solved out for a traditional solution, that we're best off putting our variable terms together first, because it's a little bit shorter to recognizing either no solution or all real numbers. But it's possible to do it either way. So these are our last two examples on solving equations. Now it's your turn to get into the homework and practice this. This is a skill that comes back for most people, but most people do need to do some practice before they feel proficient with the skill.